This video is on solid revolution, and here I have this yellow region right here, and I'm going to revolve it about the x-axis, and I want to find the volume of the solid using the shell method. And so here's the region again, the yellow region, and it's generated by the function x equal to negative y minus 2 squared plus 9. And then on the left side it's bounded by the y-axis, and then on the bottom is bounded by the x-axis. And now let's revolve it about the x-axis. And this is what the solid revolution will look like. And at the top here we have a cone, and so we want the volume of the solid without the cone. And so what we're gonna do is use the shell method, and then fill the solid revolution with what's called cylindrical shells. And here's what the shells will look like. And so for this particular example, I'm going to fill this solid revolution with 10 shells, and then I'm going to find the volume of each shell and then add the volumes of the 10 shells together, and then that will give us an approximation for the volume of the solid revolution. Here's shell number 1, and so it starts with the inner radius is 0 and then out to 0.5, and so right in the middle is 0.25, which is the average radius. And then we're going to use the 0.25 to find the height of this shell. And to get the height, we can use this equation right here, x equal to negative y minus 2 squared plus 9, and in the place of y, we would replace y with 0.25. And that will give us a height of 5.9375. And the thickness of this shell is 0.5. And volume of a cylindrical shell is 2 pi times average radius times the height and times the thickness. So we'll get 4.66 for the volume. And then here's shell number 2. And so the inner radius is 0.5, and then the outer radius is 1. So the average radius is 0.75. And so to get the height, again, we in the place of y, we would put 0.75, and that'll give us a height of 7.4375, thickness 0.5, and so the height, the volume will be 17.52. And then shell number 3, the inner radius is 1. The outer radius is 1.5, so the average radius is 1.25. And then to get the height, in the place of y, we would put 1.25, and that will give us 8.4375, and then thickness is 0.5. So the volume is 33.13 for shell number 3. And then for shell number 4, the volume is 49.14. Shell number 5, the volume is 63.18. Shell number 6, volume is 72.89. Shell number 7, volume is 75.95. And then shell number 8, volume is 69.95. Shell number 9, volume is 52.57. shell number 10, volume is 21.45. And so altogether, the volumes of the 10 shells would be 460.43. And so we can use the 460.43 as an approximation for the volume of the solid of revolution without the cone. And now instead of 10 shells, let's divide this solid of revolution into n shells. And so this would be one of the shells, and so let's call it the ith shell. So I'm going to divide the interval from 0 to 5 into n sub-intervals. And so y sub 0 would be 0, and then we get y sub 1, y sub 2, y sub 3, y sub 4, and then we get to the ith sub-interval, which is where the ith shell comes from. And then when we get to 5, that would be y sub n. If n is 5, and then the thickness of each shell will be 1. And if n is 50, then meaning we have 50 cylindrical shells, then the thickness of each shell will be 0.1. And so in general, the thickness of each shell would be 5 over n. And so let's denote the thickness of each shell as delta y. And now let's find the volume of the ith cylindrical shell. And so for the ith shell, it comes from this ith sub-interval right here. And so right here, this is y sub I minus 1. And then right here, that's y sub I. And right in the middle, let's call it y sub I star, which is y sub I minus 1 plus y sub I dividing by 2. And to get the height of the shell, then we're going to use the y sub I star, the average radius, and then along with the equation x equal to negative y minus 2 squared plus 9, which we call the g of y equal to negative y minus 2 squared plus 9. And therefore the height of this shell will be g of y sub I star. But g of y sub I star is equal to negative y minus 2 squared plus 9, and so we get negative y sub I star squared minus 2 squared plus 9. And then the thickness of the shell is delta y. The volume of the shell is 2 pi times average radius times height times thickness. And so we get 2 pi times y sub I star, and then times, that's for the average radius, and then times negative y sub I star minus 2 squared plus 9 for the height, and then thickness is delta y. And so this is the volume of the ith shell. And now let's find the volumes of n shells. So we can divide this the solid of revolution into n number of shells. So that's volume of the ith shell. And so for n shells, this is volume of shell number 1, shell number 2, and then volume of the nth shell. And using summation notation, then we get I running from 1 to n, and then with this expression. And so this is the volumes of the n shells. And so the volume of the solid of revolution is approximately this sum right here. And just like before, if we want the exact volume, then we need to divide the solid of revolution into an infinite number of shells. So let n run to infinity, and then we get this limit quantity right here. And when the limit exists, and then we would define it as the integral from 0 to 5. 0 to 5. And then here we get 2 pi, and then here we get y, and then negative y minus 2 squared plus 9, and then dy. And then simplify, we get negative y to the third plus 4y squared plus 5y. And then the integral is negative y to the 4 over 4 plus 4y to the third over 3 plus 5y squared over 2. Evaluating from 0 to 5, then we will get 875 pi over 6, which is approximately 458.15. Recorded at the beginning of the video when I divided the solid of revolution into 10 shells. Then the sum of the volumes of the 10 shells was approximately 460, which is very close to 450. And now let's find the volume of the solid of revolution here without the cone, but using the disk method. To find the volume of this solid of revolution, what we can do is find the volume of the entire solid with the cone, and then find the volume of this cone, and then subtract, and that will give us the volume of the solid of revolution that we want. So the ranges from here to up here is 0 to 9. So let's divide the interval from 0 to 9 into n sub-intervals. And so the graph here is generated by this equation right here, x equal to negative y minus 2 squared plus 9. And so let's solve this equation for y in terms of x. Then we will get y equal to the square root of 9 minus x plus 2. And this function right here is for this part. And then for this part of the graph, the lower part here, it'd be y equal to negative square root of 9 minus x plus 2. And we will need that to find the volume of this cone. But to find the volume of the entire solid, then we just use this graph right here. And so if we divide the interval from 0 to 9 into n sub-intervals, then the thickness of each slice, let's call it delta x. And so let's say that this is the ith disk right here. Then the distance from the x-axis to the graph will be, the distance will be f of x sub I. And so this is the ith disk. And so right here is x sub I. So from here to here will be f of x sub I, which is the square root of 9 minus x sub I plus 2. And if we divide this solid right here into an infinite number of slices, and then we get the integral from 0 to 9, 0 to 9, and then the pi times the square of the radius, which is this, and then times the thickness of each slice. And then evaluating this integral here will give us 297 pi over 2. So this is the volume for the entire solid with the cone. And now let's find the volume of the cone. And so the cone starts at 5 and then goes all the way over here to 9. So let's divide this interval 5 to 9 into n intervals. And as I mentioned a few minutes ago, for this graph, this part right here is negative square root of 9 minus x plus 2. And so let's denote delta x as the thickness of each slice right here for the cone. Then the radius of each slice, of the ith slice, will be from the x-axis to this graph, which is negative square root of 9 minus x plus 2. So the radius of the ith disk will be f of x of I, which is the distance from the x-axis to the graph, is negative 9 minus x of I plus 2. And if we divide this cone right here into an infinite number of slices, then we get pi, the integral from 5 to 9, and then pi times the square of the radius, which is this, and then times the thickness of each slice. And then evaluating this integral will give us 8 pi over 3. So volume of the cone is 8 pi over 3. So in summary, volume of the entire solid with the cone is 297 pi over 2. Volume of cone is 8 pi over 3. And then when we subtract, we get 875 pi over 6 for the volume of the solid without the cone. And this is the exact same answer that we got earlier when we used the shell method. And that's the end of the video.